everyone, I'm here to present the topic user authentication, finger vein pattern matching based on line tracking. The motivation for the introduction is that nowadays there are a lot of fraud cases and thefts have become very common. Thus, there was a need for strong and reliable security structure to identify the legitimate individuals has become indispensable in areas such as PC login, internet banking, and many other things like that. Conventional methods such as using passcodes, PIN to identify the authentic user has its limitation in terms of relying on an individual's memory loss or theft. Hence, personal identification based on biometric, which is the identification based on measuring an individual's psychological or behavioral characteristics, is more reliable since these features are unique to a particular individual. In this project, biometric system was designed in which personal identification was carried out based on an individual's vein patterns inside his/her finger. So first, let me give you a brief outline about the methodology. First, the hand is placed in between infrared light on black end and a camera on the front end. Infrared light is passed to the hand, which is absorbed by the hemoglobin, and the image of the vein pattern on the palm is then taken using the camera. The image contains shadowy patterns of both veins as well as irregular noise and shading due to dissimilar thickness of muscles and bones. Hence, to obtain a clear image of the veins for reliable personal identification, there was a very precise need to extract the vein patterns. In this project, extraction was done using line tracking starting at different positions. Diagrammatic representation of personal identification using finger vein pattern. So as we can see that the infrared light the infrared light over there, so once you have to place the finger inside the infrared light, the light passes and which is absorbed by the hemoglobin in the blood, and the image is captured by the camera just right behind the finger. And this whole procedure goes through a normalization and other control databases and takes the output and matches the parameters using that database. So personal identification procedure. The step 1 is to infrared image of the finger acquisition, image normalization. The step 3 is finger vein pattern extraction. Step 4 is matching, and step 5 is output of the result of identification. Now we can see in the image A that how this device has been manufactured and designed so that a finger, the picture of a finger can be viewed and can be taken. In the image B, we can see the glowing infrared image of the image of the finger. We can in the B and in the C, we can see the vein image which was exposed by the infrared light. Extraction and matching of the vein pattern. The goal of the precision of this system is to make the extraction of the vein patterns robust against irregular noise and shading. Now, this was done by repeated trials of dark line tracking, followed by extraction of the finger vein patterns. Brightness profile in the veins. Now, in the section in the figure A, we can see the brightness profile in veins cross-sectional image, and B shows us the cross-sectional view of profile. Now, and the lower diagram shows the direction of dark line. Now, the algorithm that I used was to first, the step 1, what I did was to determine the starting point of the line tracking and the moving direction attribute. Then I detected the dark line direction and movement of the tracking point. This step has the following sub-steps, which was initialization of the locus position table and determination of the set of pixels to which the current tracking point can move. The algorithm's feature extraction. Now, the step 2.3 was detection of the dark line direction near the current tracking point. Now, after doing this, the 2.4 step was registration of the locus in the locus position table TC and the moving of the tracking point. Repeated execution of 2.2 to 2.4 was carried out. Update number of times points in locus space tracked. Repeat execution of steps 1, 2, 3 to get for n number of times. A pattern of veins acquisition from locus space. Now, once you have done all the steps, then comes the pattern matching. Now, after a feature extraction, the next step in the algorithm is matching. In this process, the pattern is converted into machine data and are then compared with the recorded data. two methods are used for matching of structure, matching of template. The matching procedure is given as you can see in the red box. Locus space, the step one to do that was to first identify the locus space labeling, then the spatial reducing and labeling of the locus space, and then the data matching. Now the results were quite impressive because as you can see, the line tracking repetition was determined first, and you can see the mismatch ratio versus number of repetitions, and also you can see the matrix in which the finger vein extraction was carried out. Now as you can see, the figure A wasn't as the results were refined and into figure A.1, A.2 and A.3. You can see in A.3 the patterns are pretty visible and are pretty bright and clear. For testing purpose, an experiment was conducted to identify numerous patterns, which evaluated false acceptance FAR and false rejection error rates of infrared images of the finger. Now this was done using various data plotting techniques. Now, and the time response was 460 milliseconds per finger. That is within 0.5 seconds, which is a satisfactory result because the convention methods take about 120 seconds to 130 seconds to unlock or to recognize the user, and using the finger vein pattern, it was pretty much reduced to just 0.5 seconds. Now before summary, I'll show you the code, like how does it works.